Good morning, friends. Today I am going to explain the most important topic of mechanics, that is the principle of conservation of linear momentum. So what is momentum? Momentum is nothing but it's a product of mass and velocity is called the momentum. So here, what is the law of conservation of momentum? The total vector momentum of a system remains constant if there are no external forces acting on the system. If there is no forces acting on the system, then the total momentum of the particular system remains constant. Now this is the law of conservation of momentum. Now the linear momentum, here we have to discuss about the what is linear momentum and what is the principle of conservation of linear momentum. So statement of this principle is, here in the absence of any external force, the total linear momentum of the system remains constant. So here I have given a little bit introduction about what is linear momentum. A linear momentum P of a particle is defined as the product of its mass m and a velocity v, that is P is equal to mv. We know this one generally. Now let us suppose a system consists of a n number of particles having a m1, m2, m3 masses up to mn with velocities v1, v2, v3 and so on. Then the total linear momentum of the system in a particular reference frame is the vector sum of the momenta of individual particle. So this is the definition of linear momentum, that is P is equal to P1, P2, P3 and so on Pn. So let us suppose consider a system. A system is moving in any direction, or so that time the each particle having some mass and each particle is having some velocity. So that time the total linear momentum will be m1 v1 plus m2 v2 plus m3 and v3 and so on. Here that can be written as summation of I is equal to 1 to n mi vi. So this is the linear momentum, or this can be written as linear momentum P is equal to, this is replaced by capital letter M and VCM. So where capital letter M is the total mass, that is equal to m1 plus m2 plus m3 and so on, and VCM is nothing but a, here VCM is nothing but a velocity of center of mass of the system. Okay, that is nothing but a v1 plus v2 plus v3 and so on. Here proof of that particular theorem or statement of that, that is, what is the statement? That is, in the absence of any external force, the total linear momentum of the system remains constant. So to prove that one, here we have to consider the equation number 2, that is P is equal to mvcm. Now we have to differentiate this equation. When you differentiate to this equation, then we will get dp by dt is equal to m into dvcm by dt is equal to, we know that, so the rate of change of velocity with respect to time is nothing but a acceleration. So acm is the acceleration of the center of mass. Now but we know that according to the Newton's second law, that is F is equal to ma. So according to the second law, that is force is nothing but it's a product of mass and acceleration, or we can write that is MACM is equal to F external force, or that F external is also can be written as dp by dt. So let us take this as equation number 3. Now equation 3 shows that the rate of change of momentum of a system of particles is equal to the vector sum of external forces acting on the system. Here the rate of change of momentum of the particle is equal to the force which is acting on that particular system. Here when no external forces act on the system, let us suppose this force is 0. So when this force is 0 means dp by dt is also equal to 0. So when no external force, our definition is also that only. What is the statement? That is, when there is no external force is acting on the system, then the total linear momentum remains constant. So we have to prove that one. So for that purpose, we have considered here F external force is equal to the 0. It means dp by dt is equal to the 0. So we can write dp by dt is equal to the 0 means, here differentiation of something constant, differentiation will be 0 when it becomes 0, when the term will be constant. So it means P remains constant. So P is nothing but a P1 plus P2 plus P3 and so on. Pn is equal to constant. So this proves that the law of conservation of linear momentum. So in the next class we will talk about the law of conservation of angular momentum. Thank you. For more videos, subscribe my channel Physics.